In this session, we'll talk about the overview of a PV system. In the last sessions, we talked about how a PV cell generates electricity and how can we connect a single PV cells together to form a system so that we can have higher voltage and current. A number of PV cells will be connected together to form a PV module, and a few PV modules can connect together to form a PV array. So how can we connect them together? There are two methods. One is to connect it in series. So one PV cell connect to one another so that the voltage can increase. For example, in each PV cell is 0.5 volt. If you connect 4 together, it becomes 2 volts. So the advantages of these installations is that it can increase the voltage in the whole panel. In other words, for the same power, the current can be reduced. In other words, the I2R loss, which is the loss through the cable, will be reduced. However, the disadvantages is that if there is any problem with a single cell, let's say this single cell is dirty or the connections is broken, then the whole panel will be out of service. Okay, how about in parallel? If we connect them in this way, even one panel is out of service, then we can at least rely on another one. So in terms of reliability, parallel connection is better. However, it cannot step up the voltage. A higher voltage is better than a smaller voltage because we can use a thinner cable and also the power loss in the cable is less. Therefore, in practice, we will combine the beauty of both parallel and in series connections. So all the cells will be connected in series so that they can step up the voltage together with many different rows running in parallel to form an array, so that even though a single cell is not working, so this row is not working, but all other rows can continue the service and provide electricity supply. And there are a number of ways to connect this PV array to our energy system. A very simple concept is to use a standalone system where we have a controller to control the charging and discharging of the battery. When there is sunshine, the charge controller will control the current flow to charge up the battery. When there's no sunshine, then energy in the battery can then be released back to either using a DC loading, for example the LED lighting, or make use of an inverter to convert it to a 220 volts AC to power up any other electric appliance. So this is an example of a standalone system. We have the solar panel, we have the controller, and also the LED lighting. So you may see this in some government installations, the smart lamp pole, where during the daytime, solar panel store energy in the battery, and then during the nighttime, the battery will release energy to light up the street. And there are a number of installations in Hong Kong using this type of standalone PV system, and most of those are in the outlying islands, where it's difficult for us to connect power supplies to those areas through submarine cable. Another system is called the grid connected PV system, where we have the PV array connected to the grid connecting inverter, and then you can connect your appliance at home either to this grid connected PV system or directly to the main supply. So when there is sunlight, then these energies can be used to power up those electric appliances at home, or even excess energies can sell back to the power company. But when there's no sunlight, power company then provide power to you directly and charge your bill. Okay? So the advantages of this type of system is that it's reliable. Even though in a non-sunny day, the power company can back up the power supply. And in a very good sunny day, the excess energy can sell back to the power company. So the power company will play the role like a big battery for you to store excess energy or provide you with the power supply when you don't have enough solar energy. In recent years, the Hong Kong EMEE6002 Electrical Mechanical Service Department are now encouraging more small village to install solar energies in the rooftop and make use of this grid connected PV system so that they can feed in the solar energies back to the grid network and contributes to the development of renewable energies and productions in Hong Kong. One of the advantages of using this grid connected PV system in Hong Kong is that it can average out the fluctuations of solar intensity throughout the day. Sometimes at the noon time is higher, and then in the morning and evening is lower, or sometimes it's cloudy. So if we connect it to the grid network, so we can make use of the grid network as a big battery so that it can ensure the power supply is stable. And how about a hybrid system, which means that we make use of battery for local storage, and most of the time we can make use of the local storage and to supply power to the local loading. Or during emergency, when there's no sunshine or in the evening, then we can make use of the generator set to generate backup power supply to provide to the system. So during the normal day, a PV panel can provide power to the household or even sell it back to the power supply company. But if there's any problem with the power supply by the company, then the system and also the battery backup can continue to provide power to the household. This is an example of a hybrid PV system. In this mobile laboratory, they use PV panel to provide power supply to the indoor area in this shuttle bus, but at the same time it also have the diesel engines to provide the backup if the solar power is not sufficient. And in some building, we also install PV power to the building facade. We call this the building integrated photovoltaic system. So in the glass window and also the rooftop of the building, they are all installed with the solar panel. And some solar panel will install together with the signage board, so that on one hand it can be used as an advertisement board, and on the other hand, each of this panel will also receive energy power and play a role as a big solar panel. This is the installations in the science park. We have the canopy in the rooftop of the building to harvest solar energy. And some residential area also install the PV panel in the rooftop to provide power supplies to those common areas. Hong Kong U have started working on these PV panel installations and designs since early year 2000. And this is one of the schools in Hong Kong in Ma Wan, where they install the solar panel and at the rooftop to provide green energies for the school as early as year 2004. So the rooftop are installed with the transparent solar panel so that in the indoor area they can still enjoy sunlight, while they can enjoy sunlight in the indoor, but at the same time also harvest solar energy at the rooftop. In this particular case, we proved that the power generated by the school can support up to 9% of the annual consumptions. The installation safety of a PV panel system is also very important. So a series of panels are connected together in series will generate a very high voltage. And sometimes this high voltage can be cooling. And we need to install some safety measures, for example, diodes, isolators, and fuse to make sure that there is no overcurrent and also the high voltage will not kill the workers. And because very often those solar panels are installed at the rooftop where natural lighting may damage the panel. We don't mind if the panel is damaged by lightning. Okay? The worst case is just to spend some money to buy a replacement. But because the solar panel is connected to your household and connected to your main supply, what if you are charging your mobile phone at that time and then there's a lightning at the rooftop and this high voltage will pass through your mobile phone to your hand and you will be killed. Therefore, we need protection. We need a lightning rod at the rooftop so that if there is any lightning, then it will capture it by the lightning rod. Or all of those devices should be connected to the earth for safety purpose. And in the protection circuit, we need to add string fuse to ensure there's no overcurrent that may burn your device. And also we need the diodes to make sure that this DC current is running in one way only. Because if we connect it to any switching device, so this switching turn on and off will create a bad EMF, and this bad EMF may then pass it back to the PV panel and damage the panel. So all these safety measures have to be in place. Finally, let's talk about the advantages of using the PV panel. First, this is renewable. It's almost unlimited supply. Okay? Of course, you can argue with me that according to NASA, there's only 6.5 billion years to run. Afterwards, the sun will burn out. But we are talking about 6.5 billion years later. Okay? Probably nobody in the earth will survive. Second is abundant. The power from the solar energies is talking about 20,000 times more than the power what is required on the earth today, assuming that you can harvest all those solar energies from the sun. So it's abundant, and also it is sustainable. It does not produce any carbon gas during the operations, and also it's environmental friendly, and that's why in recent years when we want to reduce carbon emissions, solar energy is one of the best choice, and it's readily available as long as you can see the sun, and you can install this all over the world, and it does not generate any noise. It's silent, and it's even better than a wind turbine. In a wind turbine, it will generate some sound, but in solar energy, it's completely silent. And also, it can reduce your electricity cost, as the operating cost is very minimal. Once you install the solar energy panels there, there's no running cost except some annual maintenance of the system. But the annual cost will be quite low. However, the initial installation cost is still high. This diagram shows the cost for the PV panel installations across America, and then the cost that you need to install compared with the money that you can save from the installations is given by all this diagram. And what you can compare is the break-even time. So this is the money that you can save over time, and then I would like you to draw attention to this diagram to show you the payback period. In most of those areas highlighted in deep blue are those areas with payback period between 15 to 19 years. So we are talking about at least a 10 years investment, and therefore it's not that popular yet. Unlike in Hong Kong, because of the government interventions and government policy to encourage the small village to install solar panel in the rooftop. The payback period in Hong Kong is much shorter, talking about 5 to 10 years. Another problem with the solar energy is the intermittence of the solar energy. Sometimes we have energy, sometimes blocked by the cloud, and in the evening is no power. So this is not reliable, and we cannot solely rely on solar energy to power up some important system. We need to back up with, for example, the smart grid or use some backup battery. And the storage is expensive. If you use battery, then lithium-ion battery is good but expensive, and you need to think of using other means to store a large amount of solar energy. And having said that, there's no pollutions during the operations of the solar energy. But during the productions of solar energy panel, it produces a lot of pollutant gas and toxic. So this is also a disadvantage of using solar panel. And it's also use the rare metal and using some types of exotic metals, which is also quite poisoning and polluting to the environment. And one of the obstacles for the wide adaptations of solar energies in Hong Kong is the space. We don't have enough space for housing, for school. We don't have enough space for all different kinds of commercial activities. A square feet of space in Hong Kong is talking about hundreds of thousands. So all these factors are the unfavorable factors for the development of solar energies in Hong Kong. Look forward to solve this problem together.